Hi, everyone. Thank you for joining. My name is Nate McCown, and I'm the FreeFlyer Technical Support Team Manager. Today, I have the pleasure of previewing our newest release of FreeFlyer, FreeFlyer 7.9, which will be available to download later this evening. This presentation will focus on highlighting the new features in FreeFlyer at a high level, including the International Celestial Reference Frame overhaul, orbit determination, enhancements, data file updates, and overall user experience improvements. We'll briefly talk about what to expect when migrating to FreeFlyer 7.9 from previous versions. And the last thing I'll mention is that although this presentation is intended to be a high level, we will have detailed release notes covering all topics discussed today in the release notes section of the help file, which will be available in your new download of the software. The first thing we'll talk about today is the International Celestial Reference Frame overhaul. All right. The International Celestial Reference Frame, or ICRF, is the new default reference frame for all objects in FreeFlyer. ICRF is a fundamental reference frame defined by the International Astronomical Union, or the IAU. The origin of the ICRF is at the very center of the solar system, and the orientation of its axes is space-fixed, kinematically non-rotating, with respect to distant objects in the universe, mainly quasars. Because they are so distant, they are apparently stationary to our current technology, yet their positions can be measured very accurately by VLBI. Transformation between the inertial ICRF frame and Earth-fixed ITRF frame is computed in FreeFlyer using the Standards of Fundamental Astronomy, SOFA, tools for Earth Attitude software library. FreeFlyer uses the IAU 2006 and 2008 orientation model by default, but users also will have access to the IAU 2006-2000B model. We'll talk a bit more about migrating from the MJ2000 Earth inertial frame or Earth equatorial frame to the ICRF frame in the later portion of this presentation. The next thing we'll highlight is covariance in new frames and orbit determination enhancements coming along with FreeFlyer 7.9. All right, covariance and process noise are now supported in all attitude reference frames. Users will have the ability to get and set covariance and process noise in any natively supported frame. This includes RIC, LVLH, VNB, and more. One quick note is that outside of the natively supported attitude reference frames, you also will have the ability to get and set covariance and process noise in any reference frame defined by a custom coordinate system object. Along with the new covariance and process noise, we do have a new process noise rate model. This will scale the process noise added per step by the duration of noise, and users can specify which process noise model to use through the spacecraft OD properties process noise model property. We also have added two new we've added velocity light time terms to the range partial derivatives and also added state transition matrix mapping to spacecraft partial derivatives to account for light time. We'll take a quick look at one of the new sample mission plans, which demonstrates using the new covariance and process noise in new attitude reference frames. So this mission plan demonstrates the user's ability to get and set the spacecraft's covariance in frames other than ICRF. In this example, we include RIC, LVLH, and VNB. As mentioned, you can also use UVW, geodetic, and custom coordinate systems. The mission plan generates two CCSDS ephemerides with covariance, and when calling the set covariance in frame method, it takes the reference frame of the specified input, converts it into ICRF, and sets it into the spacecraft covariance. Do a quick replay of this. So in this mission plan, as you can see, the first example we're showing is RIC, and the attitude reference frames of the state sigma arrays and process noise matrices are in the RIC frame. The spacecraft's covariance are set by converting from RIC to the ICRF frame, and we've visualized that using a covariance air ellipsoid. The second example does something very similar, but in this case, we're using the LVLH frame. In that case, we're going to be converting from the LVLH frame to the ICRF frame and essentially reporting that information out to the CCSDS OEM file. All right, the next thing we'll talk about is data file updates. First thing to mention here is that the Earth orientation parameter data is now going to be using celesttrack.org data. We've also added support for CSV formatted Celesttrack space weather files. In the past releases of FreeFlyer, we've supported the legacy format by popular demand, we have also incorporated the ability to use that CSV formatted space weather data file. And we've also included the new default developmental ephemeris DE file used in FreeFlyer for determining the precise location of the solar system objects will now be DE440.data file. We still include the former models DE430, 405, etc., but the new default in FreeFlyer 7.9 and beyond will be the DE440 data file. Now we'll move into talking about user experience improvements. The first thing to mention here is that we have released FreeFlyer Certification Level 2. So after everyone has completed FreeFlyer Certification Level 1, you now have access to advanced certification modules. We've started this series off with maneuvering and targeting and coverage and contact modules. We'll continue to expand the FreeFlyer Level 2 certification, covering all modules of FreeFlyer, with the hopes of releasing orbit determination and optimization modules by the end of this calendar year. The next thing I'll mention is the FreeFlyer Users Forum. This is a dedicated website with a discussion board for users all over the world to learn about FreeFlyer from FreeFlyer team members and each other. FreeFlyer users can ask questions about the tool or engage in conversations with other users in the forum. Here you can see a quick screenshot of the tool. You can view the forum without a FreeFlyer login, but to write posts or request features, you will need to have an account. I'll quickly open up the forum so we can discuss it in more detail. So the first thing you'll see when you log into the FreeFlyer users forum is this home screen. You can set up your quick links and you have the access to 3 different discussion boards. The first is the general FreeFlyer discussion board. Quickly jump into this one. Here you can see information about how to learn FreeFlyer, how to learn or prepare for FreeFlyer Level 1 certification, and just general questions about what the tool can be used for. Go back to the users forum. The second one is the support discussion board. So here you can post your experiences with FreeFlyer to get feedback and support. You can think of this as essentially an online extension of the FreeFlyer technical support team. So if you're a current customer who needs support, obviously you can still reach out to the tech support team via email or via phone, but this is a good place to have those conversations online so there's more broad visibility for those frequently asked questions. As an example, we'll click in here. You can see a few examples of commonly asked questions to the FreeFlyer technical support team, and this is a good place to get information on that stuff. The next thing is the project showcase board. This is a really unique part of the forum. This is a good place to actually showcase the work that you've been using FreeFlyer for. So in the past, we've done examples of FreeFlyer users conferences. This is a good place for people to come and talk about their use of FreeFlyer. But if you're looking for general feedback or want to showcase a procedure that was really helpful in getting your mission plan up and running, this is a good place to share that information or those utilities with the rest of the user base. And the last thing I'll mention is the feature request. Oftentimes you would request a feature by reaching out to the FreeFlyer technical support team or talking with a team member. This is a new avenue for people to request features or enhancements to the software. You can see that you simply need to include your first and last name and then give us a little bit of detail on what exactly you're looking for in this new feature or enhancement. When you request this feature, we'll obviously create a ticket in our internal tracking system, determine the priority based on the number of asks for this new feature. And from there, you'll be able to become a beta tester for the new feature that you've asked once it's become developed. We'll jump back to the slides for a bit. Next thing I want to talk about are the new sample mission plans available in FreeFlyer 7.9. We've got a long list here. The first one we'll talk about is geostation keeping. We've got swarm formation, optimized reentry, terrain visualization, equally spaced formation, and then we've got 2 for the new RIC covariance and orbit determination enhancements. This is the get covariance in frame and process noise. We saw an example of that one earlier, and the CCSDS ephemeris with covariance. The first one we'll look at is the geostation keeping sample mission plan. This mission plan demonstrates longitude and inclination station keeping for a geosynchronous satellite through the use of box splitting. The delta V for each station keeping maneuver is calculated using a targeting loop, and the total delta V for each type of maneuver is reported after the analysis is complete. In the top right-hand corner, you can see the 2D map. This map shows the longitude deadband, which is 2 degrees centered around 75, 72.5, and 70 degrees west for each spacecraft with a maximum allowable inclination of 1 degree. In the bottom, you can see the 2 plots that are generated. On the left-hand side, we have the spacecraft longitude. On the right, you can actually see the targeting loop in action, where we're controlling the spacecraft's 1 degree maximum allowable inclination. And once we hit that threshold, you can then see that the spacecraft maneuvers such that it gets back into its constraints. If we quickly replay this, in the top right-hand corner, you can see the targeting loop and the maneuvers that are taking place for each individual satellite. Once the spacecraft is maneuvered, it will leave a point on that map, and you can see where the spacecraft maneuvers to in its next propagation. Let this play out for just a moment. You can see all the dots populating on the right-hand side, and in the top left, we have that 3D view with the spacecraft in the geosynchronous orbit. All right. The next one we'll talk about is the swarm formation sample mission plan. This sample mission plan demonstrates a swarm formation that has reached its insertion orbit. The primary satellite, that's the one that's in pink there, using an icon, that primary satellite begins its orbit raising maneuver to achieve the optimal formation for 3 satellites. The quality tracker seen in the top left-hand corner, as well as tracked in the quality plot below, is used to track the swarm formation where a value below 0.5 is failing the required formation. A value between 0.5 and 0.75 is getting closer to the ideal formation, and the value of greater than 7.75 means that the ideal formation is achieved. And the ideal formation is calculated here based on a perfect equilateral triangle. So you can see a graphics overlay that's going to be changing colors based on the quality of that formation throughout the entirety of the propagation. So a few nifty visualization tips and tricks in that mission plan for you to use in your mission plans. The next one we'll talk about is the optimized reentry mission plan. Oops, looks like my video stopped. There we go. This mission plan demonstrates satellite orbit decay impact predictions and maneuver planning for a targeted reentry. So the first thing we'll see in the top right corner, we see that 2D map. That's going to represent a 50 trial Monte Carlo. That Monte Carlo simulation is performed to illustrate the predicted reentry impact footprint. With those 50 trials of perturbed spacecraft, they're going to be propagated to the most probable impact coordinates. From there, you can see the optimizer getting to work. We're looking to optimize an optimal reentry maneuver that is calculated in order to minimize the distance between the initial impact footprint and the South Pacific Oceanic uninhabited region or area. So what we should see after the optimizer does that minimization, we'll propagate out these 50 perturbed states. We should see that all 50 states are inside that South Pacific Oceanic uninhabited area. All right, we'll talk about migrating to FreeFlyer 7.9 for just a moment. The first thing I'll mention is that millisecond timing precision mode is deprecated and will be removed in a future release of FreeFlyer. If you open a mission plan up in millisecond, you'll see that dialog box pop up. You are able to suppress this error, but we want to make sure that everyone is well aware that millisecond is coming to an end. And so that is available, or it's still available, but it is going to be deprecated, or is deprecated in this release. Apologies. In most places, which would formerly have been interpreted as MJ2000, they will now be interpreted as ICRF. So this comes as a part of the ICRF overhaul that we spoke about earlier. So let's talk about a few of those instances. The first one you'll notice is reference frame mapping. So properties, methods, and arguments that represented a state in MJ2000 Earth equator are now represented in ICRF. We can see an example of that In the reference frame drop-down box, where it formerly would have been MJ2000 Earth Equator, it is now ICRF. The next place is the solar system editor updates. The solar system .earth orientation model property is added, and this is for the two precession nutation models that we talked about previously that are available. This is only settable via the solar system object editor. The default will be the IAU 2006-2008 precession nutation model. And for clarity, 2006 represents the precession model, and 2008 or 2000B part represents the nutation model. The next thing to talk about is the solar system.np update interval property has been deprecated. The solar system NP update interval property was formerly used to control how frequently the nutation and precession are updated based on planetary ephemeris. The replacement for this is the new solar system surf evaluation mode property, which determines the surf transformation, which will be computed exactly at each point or interpolated. The interpolated mode should give the best balance of performance and accuracy for most configurations, but you do have the opportunity to use the exact, which represents computing it exactly at each epoch. The next thing we'll talk about is file updates. So the FreeFlyer ephemeris v1, 2, and 3 are now going to be generated in FreeFlyer 7.9, written in ICRF and not MJ2000 like in previous versions of FreeFlyer. Existing ephemerides will load data as if it is ICRF, and we have added a property for backwards compatibility. It is the FF-EFEM properties write backwards compatible reference frame label property. So when this property is set equal to 1, the reference frame field of the FreeFlyer ephemeris file will be written as MJ2000 rather than ICRF. This will allow resulting files to be read in FreeFlyer previous releases to 7.9. All right, so that's all I've got for migrating. The next thing I want to talk about is the future of FreeFlyer. So we'll take a brief moment. You'll see a QR code on the screen here. So one thing to note about the FreeFlyer development cycle is it is heavily dependent on user feedback. So the more requests we get for specific enhancements or features, the higher the prioritization for that request gets. So we greatly appreciate any ideas you may have. I'll give everyone about a minute or so to scan the QR code and write as many ideas as you have for new features or enhancements for upcoming versions of FreeFlyer. If you think of something after this presentation has concluded, then please feel free to submit a feature request on the users forum and we'll be sure to add it to the list. So everybody take a second, get your phone out, scan the QR code, and feel free to go ahead and start throwing a few ideas out there. See a few responses, a couple people typing. And I'll keep this poll active throughout the rest of this presentation so that you all can give us all your feedback. And from there, we'll review those results and we can review them here live to see what people are coming up with. If I go to the next slide, it'll still keep the QR code up there and we'll kind of see what things people are coming up with. You got be compatible with Windows and VMware on Mac M3, cross-platform. You got interplanetary terrain, favorites or favorite groups as data providers, icons instead of everything text. Free license for me. Well, feel free to send your contact information over. I'm sure the sales team would be happy to talk with you. Rocket objects. So I see a few things that we are tracking currently in FreeFlyer, so it's good to see that we're on the right roadmap. We've got some lunar mission plans currently. We're looking to add to that in future releases. So if you have any specific ideas that you're looking for or would like some support, a great place to start would be the forum, or you can check out our interplanetary analysis folder of the sample mission plans. Looks like it's just going in a list. We are tracking full Mac OS support in FreeFlyer 8.0, so that is good. And along with 8.0, I saw that new bullet come up. We are workshopping a better GUI. So we'll be able to, as we get closer to FreeFlyer 8.0, and just in general with FreeFlyer releases, we're always looking for beta testers to test things out before we go live. So feel free to reach out to the support team, and we're happy to set you up with some beta licenses. Updated TLEs from Celestrak seamlessly. Yeah, absolutely. Feel free to reach out to the team. We've got an example mission plan, the download TLE sample mission plan, which demonstrates how to use a socket object to pull data down from Celestrak. But if you're looking for a different or alternative route, we can certainly assist in that. Update to line layers on 2D maps. Yeah, if you're looking for more visualization stuff, I'd be interested to hear what you mean by line layers on 2D maps, or rather updates to that. But these are all great recommendations. I will be sure to add tickets to our internal tracking system, or make sure that the requesters here are added as beta testers for these future releases. So I appreciate all the feedback. And as I mentioned, if you didn't get all your thoughts out here, obviously we're only going to have this open for a few minutes. We'll be sure to review all the requests that come up in the FreeFlyer users forum. But I appreciate everyone for participating. This is great. All right, so I'll pass it off to Chris for just a moment.
Awesome. Thank you, Nate. Appreciate your time and taking us through the updates in FreeFlyer 7.9. The good news is that later today, folks will be able to go on our website and download FreeFlyer 7.9 as well. So we're going to drop that download link into the chat now. So make sure you check back later today on our website so you can download FreeFlyer. Also, definitely let us know if there are any particular questions or comments that you have, particularly regarding Nate's comments earlier, by leveraging the user forum to tell us what you would like to see in FreeFlyer 7.10 release. And then also, please use the Q&A function here in the webinar today if there are specific questions that you would like to ask regarding the software or the software release in general. We're happy to answer some of those questions now, and we'll give folks another minute or so to drop those into the chat.